Good afternoon everyone. Dear students, in our last lecture we discussed about the introductory part of dual nature of radiation and matter. In that we learned the different theories regarding the light, the actual nature of light, starting from particle to quantum via wave, that is electromagnetic wave, the different concepts related with radiation, that is characteristics of waves, characteristics of matter. The next part we have to study is the photoelectric effect or concept of photoelectric effect. So, what is photoelectric effect? So, first of all, definition of photoelectric effect. This is the phenomenon of emission of electrons from metal surface when light of suitable frequency is allowed to incident on it. So, such phenomenon is called as photoelectric effect. So, see here what is definition of photoelectric effect. So, photoelectric effect is the phenomenon of emission of electrons from metal surface when light of suitable frequency is allowed to incident on it. See here, this is violet light incident on the metal surface having free electrons. When such light photons having energy equal to h nu incident on this metal surface, the free electron absorbs energy from the photon and these electrons are emitted out of this surface, and this phenomenon is called as photoelectric effect. So, definition of photoelectric effect: the phenomenon of emission of electrons from a metal surface when radiation of suitable frequency is incident on it is called as photoelectric effect. So, this is the concept of photoelectric effect. Light of suitable frequency, it is violet or ultraviolet light having frequency nu and energy E equal to h nu or hc by lambda incident on this metal surface. These photons carries energy equal to h nu. When electrons, free electrons in this metal surface absorbs energy, their energy becomes maximum and they get excited out of the metal surface, and this phenomenon is called as photoelectric effect. So, how it takes place or what is the history behind it? So, first one, it was first discovered by Heinrich Hertz in 1887 while he was working on production of electromagnetic waves by the spark discharge, means this was invented accidentally. Heinrich Hertz was working on the production of electromagnetic waves by spark charges. In that experiment, he allowed the ultraviolet radiation to incident on the electrode, and to his surprise, the electrons were emitted from that metal surface. He observed the cloud of electron moving between the two electrodes, and he observed that phenomenon and he studied that, and then he named the phenomenon as photoelectric emission. So, photoelectric emission, it was discovered by Heinrich Hertz. So, there are some metals like zinc, cadmium, magnesium which emits electrons for ultraviolet radiation. The elements or metals like zinc, cadmium, magnesium, etc. emit electrons for ultraviolet radiation, while the alkali metals like, we may take example, sodium, potassium, cesium, etc., even tungsten also, these element emits electrons even for the visible radiation also. Ultraviolet radiation has more energy as compared to visible radiation. As we move from ultraviolet to visible, the wavelength increases but energy decreases. So, how it happens, how it takes place here? So these metals which emits electrons are called as photosensitive metals. Examples given above: zinc, cadmium, magnesium, or sodium, potassium, cesium, tungsten. These are the photosensitive metals which can emit electrons from metal surface. So see here carefully how the potassium can emit electrons even for visible light also. If you observe here carefully, this is red light of wavelength equal to 700 nanometer or 7000 angstrom unit. Using the relation E equal to h nu or hc by lambda, we can find its energy of the photon. It is equal to 1.77 electron volt, and for this light there is no photoelectric emission from this potassium. But as we move from red to green, wavelength is 550 nanometer, means 5500 nanometer. Its energy is 2.25 electron volt. When such energetic photon incident on this potassium plate, the electrons are emitted with maximum velocity equal to 2.96 10 to the power of 5 meter per second. Means the potassium plate does not show photoelectric effect for red light, but it shows photoelectric effect for green light, also for blue light of wavelength equal to 400 nanometer or 4000 angstrom unit, which is having energy equal to 3.1 electron volt. Such energetic photon incident on this potassium plate, the energy is absorbed by electrons within the potassium plate and they are emitted out of this plate, and this emission is called as photoelectric emission. And the velocity of these electrons, maximum velocity, is 6.22 10 to the power of 5 meter per second, which is greater as compared to that for green light. And for red light there is no photoelectric emission. Means it is clear that as wavelength decreases, means energy increases, photoelectric emission takes place. And from this end, if we move from violet to red, there is no photoelectric emission for red color. So this is the photoelectric effect. तर विद्यार्थी मित्रांनो, फोटोइलेक्ट्रिक इफेक्ट हेनरिक हर्ट्स नावाच्या सायंटिस्टने 1887 मध्ये अपघातातून लावलेला हा शोध आहे, जो की एक एक्सपेरिमेंट करत होता इलेक्ट्रोमॅग्नेटिक वेव्हचं प्रोडक्शन बाय स्पार्क डिस्चार्ज. आणि त्याच्या असं लक्षात आलं की इलेक्ट्रोडवर जर अल्ट्राव्हायोलेट रेडिएशन पडू दिला तर त्याच्यातून इलेक्ट्रॉन बाहेर पडत होते, इलेक्ट्रॉनचा डिस्चार्ज होत होता विदिन द प्लेट्स. आणि त्याला त्यांनी कन्क्लुजन असं केलं की हा फोटोइलेक्ट्रिक इफेक्ट असावा, ज्या अर्थी लाईट पडल्यानंतर इलेक्ट्रॉन बाहेर यायलेत. म्हणून त्याची डेफिनेशन तयार झाली अशी: द फिनॉमिनॉन ऑफ इमिशन ऑफ इलेक्ट्रॉन्स फ्रॉम मेटल सरफेस when radiation of suitable frequency is incident on it is called as photoelectric effect. काही मेटल्स आहेत, झिंक, कॅडमियम, मॅग्नेशियम असे मेटल्स, त्यांच्यावर जर अल्ट्राव्हायोलेट रेडिएशन पडला तर ते फोटोइलेक्ट्रिक इफेक्ट दाखवतात. पण काही मेटल्स असे असतात, अल्कली मेटल्स, सोडियम, सिजियम, पोटॅशियम वगैरे यांच्यासारखे, इव्हन टंगस्टन सारखे, की जे त्यांच्यापैकी काही इलेमेंट्स आहे इव्हन व्हिजिबल लाईटसाठी सुद्धा ग्रीन, व्हायोलेट, येलो लाईट पडला तरी त्याच्यातून इलेक्ट्रॉन बाहेर पडत असतात. सो असे मेटल की जे फोटोइलेक्ट्रिक इफेक्ट दाखवतात त्यांना म्हणत असतात फोटोसेन्सिटिव्ह मेटल्स. तर हा झाला फोटोइलेक्ट्रिक इफेक्ट, त्याची डेफिनेशन आणि थोडंसं हिस्टॉरिक बॅकग्राऊंड त्याच्या पाठीमागचं. पुढच्या तासामध्ये आपण त्याची एक्सपेरिमेंटल स्टडी बघूयात.